Yeah. So good afternoon to all and welcome you all for the 16th lecture on basic circuit theory. So anyone can you let me know where we are? Yes, are you with me? Where we are?
Superposition theorem.
Superposition theorem. So you know what do you mean by superposition theorem, and you know how to solve problems based on superposition principle. So now I want to define what is superposition theorem. Right? It's very important. Two more superposition theorem. Okay. So what it says, you can apply superposition theorem only for independent source, not for dependent source. Okay. So here independent source are referred as linear network or linear circuits, whereas dependent source are non-linear. Okay. The linear non-linear பத்தி ரொம்ப டீடைல்டா பேசலாம், but as per your circuit theory syllabus, it is not required. So please let me start the definition as itself. Okay. So in any linear resistive network. So how to define Ohm's law? What is the unique keyword for Ohm's law that you guys know? At constant temperature. Similarly, here the unique keyword is superposition theorem is applicable only for linear network, only for independent sources. Okay, நீ இதை மட்டும் மைண்ட்ல வச்சுக்க. Independent sources linear, whereas dependent sources non-linear. ஏன்னா அது வேற யாரோ ஒருத்தவங்களை டிபெண்ட் பண்ணி இருப்பாங்க. So obviously the nature becomes non-linear. Okay, so in any linear resistive network, what we found, okay, the voltage, we can find either the voltage across the element or the current through any element may be calculated algebraically by adding, okay, all the separate voltages or currents caused by separate independent sources acting alone okay separate independent sources. You want to switch on or you want to activate any one source, right? So then we are adding all these things, right? So that is the meaning of adding algebraically. So maybe calculated maybe calculated by adding algebraically or adding maybe calculated by adding algebraically actually. Okay, by adding algebraically all the separate voltages or currents caused by separate independent sources acting alone with all separate, okay, voltage sources, actually independent voltage sources, right? This keyword is very important. Separate independent voltage sources are replaced by short circuit and independent current sources are replaced by open circuit. Actually, this is the definition as per our director. Okay, இந்த டெஃபினிஷன் எல்லாம் சேஞ்ச் பண்ணக்கூடாது. ஓகே, அதனால நான் என்ன பண்ணியிருக்கேன்னா நம்ம புக்ல என்ன வேர்டிங்ஸ் இருக்கோ அதை அப்படியே யூஸ் பண்ணியிருக்கிறேன். பட் யூ கைஸ் யூ ட்ரை டு அண்டர்ஸ்டாண்ட் ஓகே சூப்பர் பொசிஷன் தியரம் பை யுவர் செல்ஃப் அண்ட் ட்ரை டு ரைட் த டெஃபினிஷன் வித் யுவர் ஓன் லாங்குவேஜ். ஓகே, இந்த அளவுக்குலாம் கஷ்டப்படாத. இட் இஸ் நாட் ரிக்வயர்ட் ஃபர்ஸ்ட் ஆஃப் ஆல். பட் as a faculty I want to follow okay director. So director என்ன சொல்லியிருக்காருன்னா இப்போ சொல்லியிருக்காரு. But please start with this keyword any linear resistive network. Okay, and after that you just put your own words and try to explain what is superposition theorem. Okay, so this is just language that you guys you are familiar. Just explain with your own language, nothing wrong. Okay, but this is as per our director William Henk. Okay, இது இப்போ புரிஞ்சிருக்கும்னு நினைக்கிறேன். ஜஸ்ட் ட்ரை டு அண்டர்ஸ்டாண்ட் ஓகே திஸ் வேட்டிங் சென்டர் by yourself. I don't want to explain. It's very simple. Once if you understood what is superposition theorem, then it's just definition. Okay. So shall we move? After superposition theorem, what's the next? Yeah. You want to take this? Yeah. Yeah. Take this. Take this. I will give you 2 minutes to take this. So any linear resistive network, the voltage across, either you can find the voltage or the current through any element that may be calculated. எப்படி கால்குலேட் பண்றோம்? By adding algebraically. ஓகே, எதை ஆட் பண்றோம்? ஆல் தி செப்பரேட் வோல்டேஜா இருக்கலாம் ஆர் கரண்டா இருக்கலாம். அது யாரால அந்த கரண்ட்டோ வோல்டேஜோ வந்துச்சு? செப்பரேட் இண்டிபெண்டன்ட் சோர்சஸ் ஆக்டிங் அலோன். அட் அ டைம் யூ வாண்ட் டு ஆக்டிவ் எனி ஒன் இண்டிபெண்டன்ட் சோர்ஸ். ஓகே, சப்போஸ் இஃப் யூ ஆர் ஹேவிங் டிபெண்டன்ட் சோர்ஸ், don't touch the dependent source. Okay, because the nature becomes non-linear. But this is only applicable for linear resistive network. Okay, so you want to replace voltage source by short circuit and current source by open circuit. Okay, so that is the thing. Once if it is taken, then let me know. Then we will move to the next theorem.
Okay, sir.
Yeah. So what's the next theorem after superposition? We are having. Yeah. Can you go to my syllabus overview page? So the next theorem, it is Thevenin's and Norton's. Okay. First we will discuss Thevenin's theorem. Okay. So let me put the heading Thevenin's theorem. Then later we will discuss Norton's theorem. Once if you know Thevenin, then do the reverse thing, then you may end up with Norton. That we will discuss, you don't worry. So first put the heading Thevenin's theorem. And take this problem. Straight away I will like superposition எப்படி அப்ரோச் பண்ண அந்த மாதிரி இப்போ straight away we will approach Thevenin's theorem. One example, then you can understand what is Thevenin. Now take this problem. As I told earlier, entire second unit. Okay, if you know mesh analysis, that is more than sufficient. Mesh analysis, mesh voltage division rule, current division rule. Otherwise, KVL, KCL. If you know these fundamental, then remaining the entire 2 unit becomes easy for you people. So take this is some 9 volt, this is some 2 ohm, 3 ohm, 4 ohm, 4 ohm. This time let me take one more resistance here, 6 ohm. Now my question for you people, find I sub 2 ohm. Can you find by yourself? Compute I sub 2 ohm. Take your own time. I will give you enough time. Okay, and this time I won't solve this problem. Very simple. Mesh analysis with too low. Okay, so find the current which is flowing through 2 ohm and let me know the value. Apply mesh analysis. Okay, obviously. Find I1 and I2. I2 will give you the current which is flowing through 2. So that is the. So for your reference, okay, here I am writing the equation. Loop 1, I am having 3 resistance, 4, this 4, this 6, 4 plus 4, 8, 8 plus 6, 14, so 14 and 1 minus, this 4 is common, so minus 4 and 2 equals, this is minus 2 plus, when it goes to right hand side, it becomes 9, equation number 1. And coming to equation number 2, 5, 2, 4, 3 registers in I2, 5 plus 4, 9, so 11 I2, 4 is common with I1, minus I1 equals 0. Equation number 2, by solving, நேர சொல்லியிருக்கணும் ஆன்சரு 1 and 2. What is my
Sir,
I1?
I1 0.7173.
0.7173, very good. Amps
I2 0.2608 amps.
0.2608 amps. Okay, very good, thank
Sir,
you.
equation la plus
So
11
now see
item.
the. Thank you, thank you, thank you. So now see the beauty. You know what I am going to do? You know, as per Thevenin, that great man, you know, what he has found. Now take this 2 ohm, right? Take this 2 ohm as load. As load means load resistance. Okay. Load means whatever it may be. It may be the fan, this is a load. Maybe the dew plate, that is a load. Maybe your TV, you are connecting like that is a load. It has some internal resistance. Okay. So now take this is some load. Okay. And the current which is flowing through the load is 0.2608 amps. That you know. Okay. So now except this load, I am having the remaining things, right? That can be replaced by a single voltage source in series with a resistance. That is the beauty of this guy. Above circuit is somewhat complex, right? This circuit is somewhat complex. இங்க நான் வந்து only 3-4 ரெஜிஸ்டர் வித் ஒன் வோல்டேஜ் சோர்ஸ் சப்போஸ் அசியூம் ஒரு பெரிய இண்டஸ்ட்ரி அதோட எலக்ட்ரிக் கனெக்ஷன் யோசிச்சு பாரு அதுல என் நம்பர் ஆஃப் வோல்டேஜ் சோர்ஸ் என் நம்பர் ஆஃப் கரண்ட் சோர்ஸ் என் நம்பர் ஆஃப் ரெஜிஸ்டர்ஸ் என் நம்பர் ஆஃப் லோட்ஸ் இருக்கும் இல்லையா பட் எனக்கு ஏதோ ஒரு லோடுல ஃப்ளோ ஆகிற கரண்ட் வேணும் அப்ப நான் என்ன பண்ண போறேன் ரிமைனிங் லோடு எல்லாத்தையுமே ஐ கேன் ரீப்ளேஸ் பை எ சிங்கிள் வோல்டேஜ் சோர்ஸ் இன் சீரிஸ் வித் எ single resistance. This voltage source is called, because it is found by Thevenin, that's what it is called, V Thevenin, and this resistance is called R Thevenin. Now connect this load to ohm in such a way, actually you want to get the same 0.2608 ampere must flow. That is the beauty. Okay, current or what is the voltage across this 2 ohm here? What is the voltage across 2 ohm? That 2 times 0.2608, that will give you some value. Here also you will get the same 2. Okay, 2 times 0.2608. So not only the current, that may be the voltage also. It never change. Same voltage you will get. So now see the beauty. But now, what is the value for VTH and what is the value for RTH? So now got the idea. What is Thevenin? Thevenin என்னன்னா Thevenin அப்புறம் ஆட்டோமேட்டிக்கா மைண்ட்ல என்ன வரணும்னா first you want to ask which one is load. Okay, so load will be given. So now, except that load, the remaining circuit can be replaced by a simple voltage source in series with a resistor. That voltage source is called V Thevenin and that resistance is called R Thevenin. So now we will find VThevenin and RThevenin. After that, you find I2 ohm. You will get the same current. Then you will enjoy it. I hope so. Okay. So now, what is the procedure to calculate VTH and RTH? Okay. So before telling the procedure, actually in Thevenin or Norton, next case Norton. Any idea what do you mean by Norton theorem? Any guess at least? Anyone? This is called Thevenin. So this complex circuit can be replaced by a single voltage source in series with a resistance. Now coming to Norton, I'm drawing here. Okay, the same load. Now this time we will take the same load. Okay, but this time this complex circuit, okay, can be replaced by Thevenin ஒருத்தர் கிளம்பினாரு. அவர் என்ன பண்ணாரு அப்படின்னா, let me read. அவர் என்ன பண்ணாரு, இதை வந்து வோல்டேஜ் சோர்ஸ் இன் சீரியஸுக்கு ரெசிஸ்டன்ஸ் சொன்னாரு. நம்மால் நாட்டன் கிளம்பினாரு. சேம் என்ன பண்ணலாம், இன் கரண்ட் சோர்ஸ் இன் பேரலல் வித் சம் ரெசிஸ்டன்ஸ். இப்ப now find I2 you will get this, you want to get the same current. Okay, current won't be varied, right? So 0.2608 amps you will get. So don't worry. So now this voltage which is called, because of Norton it is called Norton current, and this is because of Norton, this is called Norton resistance. So ஒரு காம்ப்ளெக்ஸ் சர்க்யூட்டை ஒரு வோல்டேஜ் சோர்ஸ் இன் சீரிஸ் வித் ரெசிஸ்டன்ஸ் வச்சு வெரி ஒரு வோல்டேஜ் சோர்ஸ் இன் சீரிஸ் வித் ரெசிஸ்டன்ஸ் ரெப்ரசென்ட் பண்ணேன்னா தட் இஸ் கால்டு தெவெனின். வாட் யூ மீன் பை நார்டன்? அதே காம்ப்ளெக்ஸ் சர்க்யூட்டை ஒரு கரண்ட் சோர்ஸ் இன் parallel with a resistance வச்சு replace பண்ணா that is called Norton. We will discuss one by one. So now actually in Thevenin you are having three cases. Thevenin or Norton, whatever it is, okay, you are having three cases. Case one, all are independent sources. All are independent sources. It may be voltage source or it may be current source. But circuit இங்க பாரு, இப்ப நான் எடுத்த ஃபர்ஸ்ட் எக்ஸாம்பிள் என்ன இருக்கு, ஒரே ஒரு வோல்டேஜ் சோர்ஸ் தான் இருக்கு. It is dependent or independent? Yeah, obviously independent. So இது it will come under case 1. Case 2, at least one dependent source. At least one dependent source means, what about independent source? N number of independent source. Just for your reference I am writing. So n number of independent source. That is not a matter. But the thing is, you want to have at least one one dependent source. At the time you want to approach some other way. Now case 3, all are dependent sources. There is no independent source. Okay, all are dependent source means no independent sources. Okay, so they may give any circuit. First you want to find, okay, in which category it falls. It may fall case 1 or case 2 or case 3. For each category we are having separate procedure to calculate this VTH and the RTH. Okay, it's quite interesting. Don't worry, I will let you know one by one. So first இப்ப நம்ம என்ன கேட்டகரியில இருக்கிறோம், all are independent source. Okay, but most probably for you people they will ask question from this area only. Case 1, it's very important. Okay, sometime case 2, and they never ask case 3. You don't do it. Okay, in a gate point of view, it's important for electronics, electrical, triple and EC people. But anyway, we will solve at least one problem. Okay, to enjoy ourselves in case 3. We will solve enough problem on the case 1 and 2. Don't do it. So now take this example 1. In which category it falls? It is coming under category 1. Okay, so all are independent sources. So now take case 1. If all are independent sources, at that time, what is the procedure to calculate VTH. So write procedure to calculate VTH. Okay. என்ன ப்ரொசீஜர்னா ஃபர்ஸ்ட் ஐ வில் கிவ் யூ த ப்ரொசீஜர் தென் ஐ எக்ஸ்பிளைன். ஒன்லி டூ ஸ்டெப். ஃபர்ஸ்ட் ஸ்டெப், you want to open the load. Open the load or simply ஒரே ஸ்டெப்ல எழுதிடுறேன். And find the voltage across it. That voltage is your VTH. So procedure to calculate VTH. What do you want to do? இது பெரிய ப்ரொசீஜர்லாம் ஒன்றும் இல்லை. ஜஸ்ட் உனக்கு ஒரு என்ன சொல்றது, ஒரு கோர்வையா நடத்தணும் அப்படிங்கிறதுக்காக ஒரு ப்ரொசீஜர்னு கொடுக்குறேன். தட்ஸ் இட். ஓகே. Future it will help you. So what do you want to do to calculate VTH? You want to open the load and find the voltage across the opened circuit. எங்க நீ ஓபன் பண்ணியிருக்கியோ அந்த இடத்துல உள்ள வோல்டேஜ் கண்டுபிடிக்கணும். That will give you VTH. That we will solve at the time you can understand. So now, what is the procedure to calculate RTH? Okay, procedure to calculate RTH. Okay, here the procedure is very first point. Suppose if you are having independent voltage source, so replace independent voltage source by short circuit. Second point, replace independent current source by that open circuit. Okay, இதை replace பண்ணிட்டு then third point, now open the load and this time find the resistance across it. Find the resistance across it. Okay, now take the procedure. I will solve one problem, then automatically you can understand this procedure. Okay, so now take this. So case 1, if all are independent sources, at that time how to find VTH and how to find RTH. The procedure is given. It's very simple. To calculate VTH, okay, just open the load and find the voltage across it. You will solve it. To calculate RTH, actually you want to replace all independent sources by its internal impedance. அப்படின்னா என்ன அர்த்தம்? You want to replace voltage source by short circuit, current source by open circuit. அதுக்கப்புறம் என்ன பண்ணணும்? You want to open the load open பண்ணிட்டு அங்க கண்டுபிடிச்சிட்டு ரெசிஸ்டன்ஸ். Okay, I hope so you will enjoy this. So now have you taken this? Have you taken this procedure? If it is taken, let me know. Then we will solve the first problem. For first problem, we will find VTH and RTH.
Yes, sir.
Yeah. So what is the first problem? Let me draw one second. Okay, the first problem I have given this problem, right? So now take example 1. Yeah, take the same problem one second. This is my 9 volt. I hope so. This is 2 ohm and this is 5 ohm. These both are 4 ohm and this is 6 ohm. Okay. Now what is the load? The load is given. The question is find the Thevenin equivalent circuit across 2 ohm. So what it means? Here they have given RL equal to 2. Okay. So let me give the solution. The solution. Okay. So what we are going to do now? This is my load, and I am going to replace this entire thing by a single voltage source in series with a resistor. That obviously you know. A single voltage source in series with a resistance. So this voltage source is VTH. This resistance is RTH. So solution, first A to find VTH. Yeah. So listen me carefully. What is the procedure to calculate VTH? Yeah. What is the procedure to calculate VTH? You want to open the load. So now listen me carefully. What I am doing, I am opening the load. Okay. Open the load and find the voltage across it. And find the voltage. This is my VTH. Okay. Now listen me carefully. Now what is VTH? Once if it is opened, what is the current which is flowing through this 5 ohm? Anyone? Once if I
Zero.
open the load, micro 0. So 0 means R equal to 0. So this actually this is short circuit. So can I remove this? Since the current is 0, right? Okay. So here also this can be removed. Okay. So now what is VTH? Anyone? Can you move this VTH? Plus minus. Now this is my VTH. Therefore, what is VTH? The voltage across 4 ohm. Can you understand? I repeat, சர்க்கியூட் எப்படி இருந்துச்சு? இங்க ஒரு 5 ohm, இங்க ஒரு 2 ohm. Okay, now the 2 ohm actually it is my load. What is the procedure to calculate VTH? You want to open the load. So load என்ன பண்றேன்? Open பண்ணிடுறேன். And find the voltage across it. This is my VTH as per procedure. இப்போ இந்த VTH என்னது? இங்க எனக்கு கரண்ட் ஃப்ளோ ஆகல, ஸோ இது 0 ஆயிரும். இப்போ இந்த VTH அப்படியே மூவ் பண்ணி பார்க்கலாம். அப்போ வாட் இஸ் VTH? The voltage across this 4 ohm, right? The voltage across this 4 ohm will give you VTH. Okay. So now, how will you find the voltage across this 4 ohm? Anyone? Actually, here I am redrawing. So actually, what is there? I am applying some 9 volt. இங்க எனக்கு எவ்வளவு இருக்கு? 4 ohm இருக்கு. இங்க again some 4 ohm. இங்க 6 ohm. I want to find this voltage VTH, the voltage across 4 ohm. Either you can apply KVL or simply by VDR. Okay, applied voltage 9 into same resistance divided by total resistance 4 plus 4 8, so 14. So what is this value? Can you understand how I am finding VTH? It's very important. So what is this value? 9 times so 36 divided by 14. How much more?
2.57.
So this is the way to calculate VTH. Please take down. Have you taken? To find RTH. Okay. So now actually this is my original circuit, right? Yeah. To find RTH, what is the procedure? You want to replace this voltage source by short circuit, right? So this voltage source by short circuit. For here I am drawing. So voltage source by short circuit. Remaining என்ன இருக்கு? This is my 4 ohm. This is my 6 ohm. And this is my 4 ohm. Actually, this is my 5 ohm, right? So this is my 5 ohm. Yeah, this is my 2 ohm. So this is 4 ohm. This is 4 ohm. This is 6 ohm. This is 4 ohm. First step over. And do you have any current source? No. Third step, and you want to open the load and find the resistance across it. That will give you RTH. Okay. Now how will you find the equivalent resistance? That as I told earlier, suppose if you want to find the equal resistance at this side, then you want to start from the opposite side. Okay. Now how this 4 and this 6, how they are connected? So this time our golden rule will help you. 4 6. Okay. அதில் எப்படி இருக்குன்னு பாரு. So terminal 1, this is terminal 2, terminal 1, terminal 2. Only one terminal is connected. So both 4 and 6 are connected in series. Okay. So 4 and 6 are connected in series. That will give you 10. After that, I am having this 4 ohm. Then I am having this 5. Okay. Now this is my RTH. So now how 10 and 4 are connected? How 10 and 4 are connected?
Parallel.
Guys, are you with me? So parallel, it's very simple, right? Both the terms are connected. So parallel. So what is the equivalent? This is 10 parallel with 4 in series with, actually this is my 5 ohm, and now this is my RTH. What is 10 parallel with 4? Anyone? 10 times 4 divided by 10 plus 4, 40 divided by 14. How much? 40 divided by
2.5, 2.857. 857.
2.86 வச்சுக்கிட்டா
Okay.
2.86. So now this is my 2.86. So 2.86 and 5 ohm. How they are connected? According to this terminal, both are connected in series. So 2.86 plus 5 will give you 7.86. This is the way to calculate RTH. So just apply the procedure. Okay, you want to replace voltage based art circuit and open the load and find the voltage across it. Sorry, find the resistance across it. Suppose if you want to find the resistance across these terminal, then you want to start from the opposite side. Just simplify. Network reduction already படிச்சிருக்கோம். Okay, so you know how to simplify this circuit. At last you will end up with 7.86. புரிஞ்சா? Now you can verify. I told you earlier. Now this, what is this VTH? It is, what is this value? VTH எவ்வளோமா? 2.57 volt. Now see the beauty. 2.57 volt. இங்க என்ன இருக்கு? 7.86 ohm. This is my RTH. Now connect the load. Now connect the load. 2 ohm. Now find this I sub 2 ohm. How will you find this I sub 2 ohm? That I equal to V by R, where V equal to 2.57 divided by R equal to 7.86 plus 2, since both are connected in series. So 2.57 divided by 9.86. What is this value, ma? Anyone?
0.26.
Approximately 0.26 ampere. Okay, so we got the same current in your original circuit. Actually, what is the current which is flowing through this first? What's the current? 0.2608 approximately. So here also it is 0.26. Okay, so this is the way actually to verify. But the question is find the Thevenin equivalent. You just calculate. Okay, you just find this circuit. This is enough. Okay, and just draw the Thevenin equivalent circuit finally. So now this is your Thevenin equivalent circuit. See the beauty. எவ்வளோ ஒரு காம்ப்ளெக்ஸாக ஒரு சர்க்கியூட்டு அது நம்மளால் தெவனின் எவ்வளோ தெளிவாக ஒரே ஒரு வோல்டேஜ் சோர்ஸு இன் சீரிஸ் வித் ஒரு ரெசிஸ்டன்ஸ் போட்டார். ஓகேங்களா? இட்ஸ் பியூட்டி, ரைட்? ஸோ தட் இஸ் த பவர் ஆஃப் தெவனின்ஸ் ஈக்குவலன்ஸ், தெவனின்ஸ் தியரம்.
சார் கொஞ்சம் மேலே ஸ்க்ரோல் பண்ணுறீங்களா சார்?
So you guys, you take this and let me know, and we will solve one more problem. So this is the procedure, okay, for all our independent sources. எல்லாமே இண்டிபெண்டாக இருந்துச்சுன்னா this is the way to play. But you guys, you don't worry, உங்களுக்கு மேக்ஸிமம் எல்லாமே இண்டிபெண்டன்ட் சோர்ஸாக தான் இருக்கும். பட் ஆக்சுவலாக டிபெண்டன்ட் சோர்ஸ் இருந்துச்சுன்னா the procedure becomes easy, that I will teach you. Okay, so now take this. Once if it is taken, please let me know, then I will move to the next problem. We will solve one more problem, then you can understand.
ஓகே சார்.
Okay, suppose if you will find Norton theorem for the same circuit, what you will get? Any idea? Norton equivalent. From Thevenin, actually it is easy to calculate Norton. How will you calculate Norton theorem from Thevenin? Anyone? Any genius people? Just to think, nothing wrong. What do you mean by Norton? Same complex circuit can be replaced by, so there is no change in the load. Same complex circuit can be replaced by a single current source in parallel with a resistance. This is my 2. This is my I sub 2. Now this is my Rn. What could be the value for Rn? What could be the value for In? Any idea? Yeah, படிச்சிருக்கோமா? Anyone? இந்த சர்க்கியூட்டை
Force transfer.
இந்த மாதிரி மாற்றணும். Yeah, very good. Thank you. Thanks a lot. So just apply source transformation theorem, then you will end up with Norton's theorem. So what could be the value for In? Anyone? In equal to, what is the value? I equal to V by R. So here VTH divided by RTH. What's the value? VTH 2.57, RTH 7.86. What is this value? Anyone?
.326 sir.
Just இது வந்து shortcut method. This is shortcut
0.326
method. Okay, how to write once to click. Yeah, 0.326. So 0.326 amps. What is the value for Rn? The same RTH will come, right? So Rn equal to RTH. It is 7.86. Okay, so in Norton theorem, what is the procedure to calculate RTH? It won't vary. அங்க ஆர்டிஹெச்சும் நார்டன் தியரமும் ஆர்ன்னு சொல்றோம் இல்லையா, அந்த ஆர்னுக்கான ப்ரொசீஜர் என்ன? How to find RTH? The same procedure, but we want to calculate IN. That procedure I will let you know, you don't worry. But there is no change in the procedure to calculate RN. Same procedure. Okay, what we followed for RTH? RTH க்கு என்ன procedure follow பண்ணியோ same procedure follow பண்ணி to calculate RN. Okay, so now can you find I sub 2 ohm and verify are you getting I sub 2 ohm equal to 0.26 ampere or not? Yeah, obviously you will get right, but we will verify by CTR, by current division rule. What is my I sub 2 ohm? Applied current into opposite resistance divided by total resistance. What is this value? If you will calculate, obviously you will get 0.26. So this is Norton's theorem from Thevenin. From Thevenin. Okay. But what is the value for IN? It's very important. 0.326. So now put the heading Norton's theorem. Norton's theorem. So here first you want to calculate IN, Norton current. So procedure to calculate IN. What is the procedure to calculate VTH? Can you remember that? What do you want to do? You want to open the load. Okay, you want to open the load and find the voltage across it. வோல்டேஜ் கண்டுபிடிக்கணும்னா லோட ஓபன் பண்ணிட்டு அதுக்கு அக்ராஸ் உள்ள வோல்டேஜ் கண்டுபிடிக்கணும். இப்ப கரண்ட் கண்டுபிடிக்கணும் என்ன செய்யணும்? எனி ஐடியா? கரண்ட் கண்டுபிடிக்கணும் என்ன செய்யணும்? எனி ஐடியா? அங்க ஓபன் பண்ணணும் லோட. இங்க லோட என்ன பண்ணணும்? ஸ்டார்ட் பண்ணணும். Yeah, start the very good, very good. Start the load and find the current through it, right? Voltage across, current through. That is the keyword as I told earlier. So sort the load and find the current through it. Okay, that is the procedure to calculate IN. Now what is the procedure to calculate RN? Procedure to calculate to calculate RN. The same procedure. Okay, to calculate RTH. But anyway, I want to repeat for you people. Okay, first என்ன பண்ணணும்? First step replace same procedure ma, but just rewind பண்றதுக்காக நடத்திட்டு இருக்கு. Replace voltage source by short circuit. Replace current source by open circuit. Open the load and find the resistance across it. Okay, so now shall we solve the problem? Now take the same problem. Let me take the same problem, the same circuit, but this time we are going to calculate Norton equivalent circuit for this circuit. Take the same problem. Example 2. Find Norton's equivalent circuit across 2. Solution to find Norton current, to find IN. So what is the procedure? So this time procedure is very simple. What do you want to do? You want to sort the load. So just to make a short circuit and find this current, find the current through IN. Okay, so this take as per our earlier discussion, take I1, I2, and what is IN? IN equals I2. So can you find the IN? So to find IN, what's the procedure? Start the load and find the current through it. So I made a short circuit, and now this IN, this is my IN. So simple application of mesh analysis. If we will calculate, you will get 4 plus 4, 8 plus 6, 14 I1 minus 4 I2 equals 9, equation number 1, minus 4 I1 plus 9 I2 equals 0. Now by solving equation number 1 and 2, what is my I1, what is I2? Anyone?
Sir, I1 0.736 amps, sir.
I2?
0.327, sir.
ஏதாவது புரிஞ்சுக்க முடியுதா இப்ப? That for what is my IN? It is equal to I2. It is 0.327 amps. Actually, this one is expected, right? Already we found IN. Can you remember? From Thevenin equivalent, I found IN. What is the value for it? You are number 0.326. வந்துருச்சா? So in this way also you can verify. So now to calculate, what's the next one? To find Rn, but this time I don't want to calculate Rn. You know Rn equal to RTH. It is again 7.86 ohms. Okay, so therefore the Norton equivalent circuit, Norton equivalent circuit, one current source in parallel with one resistance, and finally connect the load. The load is 2 ohm. This is my 7.86 ohm, and this is 0.327. Now if you find I2 ohm, you will get the same answer. Okay, so now this is my Norton equivalent. So got the idea. First theorem என்னங்க தெளிவா புரிஞ்சுக்க. Then you can play, okay, for any circuit. Have you taken this? If it is taken, let me know. Then we will solve one more problem, then we will wind up. Okay. I will leave you by 1:05. In my watch, now the time is 12:59. So I will take 6 more minutes. That's it. Is it okay? We will solve one more simple problem. Okay. We will find the Thevenin and the Norton equivalent for the third problem, and we will wind up. Can I move? This time, the question is find Thevenin's and Norton's equivalent circuit. Okay. So this time across 1 kilo. So it's my another favorite problem. Favorite அப்படினால உன்னை ஏதோ கன்ஃபியூஸ் பண்ண போறேன்னு அர்த்தம். Check this problem. So this is my load, 1 kilo ohm. Take this is 2 milliamps. Okay, and take this is some 4 volt. This minus. Take this is some 2 kilo ohm. And this is some 3 kilo. No, across 1 kilo. So this is your load. So this is my load. Load R. Okay. First, to find Thevenin equivalence. இது மட்டும் நான் கண்டுபிடிக்கிறேன். You guys, you find not on by yourself. Okay. Not on the easy. To find Thevenin equivalence. Thevenin மட்டும் லைட்டா ஒரு சின்ன பாயிண்ட் நான் சொல்லி முடிச்சிருக்கேன். To find Thevenin equivalent circuit, அதில் first என்ன கண்டுபிடிக்கணும்? To find VTH. First we will find Thevenin voltage. Okay. What is the procedure to calculate VTH? And the original diagram I replace பண்றேன். What do you want to do? What is the procedure to calculate VTH? It's very simple. You want to open the load, yeah, opening, and to find the voltage across it, right? You want to open the load, yeah, and opening. Yeah. Now find the voltage across it. Once if it is open, so what is the current which is flowing through this 3 kilo ohm? It is 0. So I can replace this one also by short circuit. This is already short circuit. Huh? So now what is VTH? The voltage across this 2 milliamps. How will you find a VTH this time? Last time it was registered. So simply you apply KVL. But இங்கே எனக்கு என்னவா இருந்தா என்ன? Just apply KVL. See the magic. Actually this is my plus minus VTH. The voltage across this 2 milliamps. Okay. The 2 milliamps in the direction of flow right this time anti-clockwise. 2 milliamps is flowing. Yeah, no problem. Now take, so always current entering is positive, leaving is negative. What is the voltage across this 2 kilo ohm? V equal to I times R, where I equal to 2 milliamps and R equal to 2 kilo ohm. Yeah, that is the voltage. Now simply apply KVL at this loop. Apply KVL minus 2 plus, so minus VTH plus 2 minus, so plus 2 milliamps into 2 kilo ohm plus 2 minus plus 4. Is there any other voltage? No, equal 0. I'm looking for VTH equals VTH in the right hand side. So what is 2 milliamps into 2 kilo ohm? That you know, milli and kilo get cancelled. So you will get a 4 plus 4 8 volt. So this is the way. சின்ன ட்ரிக்கிங்க தான். ஒரு கரண்ட் சோர்ஸை டக்குன்னு பார்த்த உடனே லைட்டாக பயப்படுவ ஜெர்க்காக ஆகாத. Whatever it may be, the voltage across it, that is my VTH. Okay, that is the unknown value that I don't know, but I know the direction. Okay, this is my ground, so it is minus, it is plus. I know the polarity. So simple application of KVL will give you VTH. So now this is the way to calculate VTH. To find RTH, so this time listen me properly. Let me draw the original circuit. Okay, original circuit la என்ன இருந்துச்சு? ஒரு 2 kilo ohm, right? Yeah, 2 kilo ohm. Yeah, 1 kilo ohm. 1 kilo ohm. So what is the procedure to calculate RTH? You want to replace this voltage source by short circuit. Okay, this voltage source by short circuit, current source by open circuit. அப்போ இங்கே உள்ள கரண்ட் சோர்ஸ் என்ன பண்ணிக்கலாம்? ஓப்பன் பண்ணிக்கலாம். ரிமைனிங் என்ன இருக்கும்? ஸோ ஐ ரீப்ளேஸ் திஸ் வோல்டேஜ் பை ஷார்ட் சர்க்யூட். இங்கே ஒரு கரண்ட் இருந்துச்சு, அதை ஓப்பன் பண்ணிட்டேன். சரியா? இங்கே ஒரு 2 kilo ohm, இங்கே திஸ் இஸ் 3 kilo ohm, ரைட்? 3 kilo ohm தானே? It's not 2 kilo. It is 3 kilo ohm. Okay, இங்க எனக்கு என்ன இருக்கு 1 kilo ohm. 1 kilo ohm. அதுக்கப்புறம் என்ன பண்ணணும்? You want to open the load and find the voltage across it, right? So I am opening the load and find the resistance. That is RTH. So now what is RTH? We open one time. It's very simple. RTH equal to both are connected in series. So 5 kilo ohm. So what is the Thevenin equivalent circuit? VTH in series with RTH. Okay, where VTH you know 8 volt, RTH you know 5 kilo ohm. Then connect this 1 kilo as load. So now this is my Thevenin equivalent circuit. Suppose if you will find Norton, you please find Norton's equivalent circuit by yourself. But I will give this final answer. Okay, and you know how to convert Thevenin into Norton simply by applying force transformation. Okay, in this time there is no change in RTH, so no change in load also. But what is my I? Since this is my Norton, IN V by R, where V is 8 and R is 5 kilo ohm. So this will give you 1.6 milliamps. Please verify IN, are you getting 1.6 milliamps or not? So that's it for today's class. So thank you. So any doubt? இதான் Thevenin Norton. That's it. Yes, are you with me?
Yes, sir. No doubt, sir.
Okay, okay. So screen ஓகேவா நோட் பண்ணிட்டீங்களா? You first find Norton by yourself. Okay, and tomorrow we will solve some more problem on case 1. Then slowly we will move to case 2. So most probably by tomorrow we will try, I mean not by tomorrow, next week, right? Next Monday, and we will complete this Norton and theorem. அதுக்கப்புறம் my favorite theorem, you know, where I applied maximum power transfer theorem. It's quite interesting theorem. அது ஒரு 1 hour or maximum 2 hours. Most probably by next weekend I will complete unit 2. Okay, most probably by next weekend. நான் சொன்னேன்ல யூனிட் 2 ரொம்ப ஜாலியாக இருக்கும்னு. I hope so you guys you are all enjoying. Okay, just you want to know the procedure. So remaining everything you are playing with, and once again mesh analysis or KCL or KVL or otherwise voltage division rule, current division rule, source transformation. நம்ம ஃபர்ஸ்ட் யூனிட்ல படிச்சது தான். Nothing new. Okay, thank you.
Thank you, sir.
So thanks
Thank
for
you.
your attention. I will stop the recording. Yeah, thank you. Thanks for your attention.